Hey guys, welcome back. In this video, we're going to take a look at the graphs of sine and cosine, and we'll start to see how they look like waves, how they repeat, and some of the properties that these graphs have. All right, so when it comes to sine and cosine, we've mostly been talking about, actually we've entirely been talking about sine and cosine in terms of the unit circle. So on my screen, as you can see, I have the filled out unit circle. And as we mentioned in the past, all of the x values on our unit circle are the cosine values, and all of the y values are the sine values. And what we're going to start to do with sine and cosine is think about them as functions, as I mentioned in the past, and specifically functions where the input is some angle theta around the unit circle, and then our output is the sine or the cosine value of theta. So in other words, if our input is theta, then the output for our function y equals sine theta is going to be sine theta, or the y values that we see on our graph to the left. So another way to think about this is for our function y equals sine theta, we're trying to write a graph. So one thing we can do is start off with a table. So we have our inputs and we have our outputs, theta and sine theta. And we can start off, we know that at 0, sine of theta is 0. And then we know all of our special points around the unit circle. So using radians at pi over 6, our sine value is the y value that we see for these points. So our sine value is 1/2. For pi over 4, our sine value is root 2 over 2. For pi over 3, we have root 3 over 2. And then finally, for pi over 2, sine is at its maximum value, 1. So we can start to graph these. I'm going to scroll down a little bit. So here we have theta. On the y-axis, we have sine theta. And we're starting off with a few points. So 0, 0. We know that at pi over 3, or sorry, pi over 6, we have 1/2. 1/2. At pi over 4, we have root 2 over 2. At pi over 3, we have root 3 over 2. And then finally, at pi over 2, we have 1. So maybe our maximum up here is 1. So not labeled super well, but you can kind of see how it's increasing as we go to the right. And then next, as we go past pi over 2, our y values go back down because 1 is our maximum. And we actually end up seeing kind of like a repeat here, where if we look at 2 pi over 3, we end up with root 3 over 2. So another way to think about it is we're going backwards, root 3 over 2. So then next up we have 3 pi over 4. And our output is going to be root 2 over 2. 5 pi over 6. We keep going backwards, so 1/2. And then finally at pi, we end up back at 0. So we have 2 pi over 3. And we're back at root 3 over 2. Then 3 pi over 4. We have root 2 over 2. We're back at 1/2 when we reach 5 pi over 6. And then finally, when we get to pi, we're back at 0. Okay. All right, so if we start to connect our points, you can see we end up with what's starting to look like a U shape in a way. But not really a parabola, so kind of like this dome shape to start. When we keep going on our table, we would keep looking at these y values as we go around the circle. And what ends up happening is, as you can see, our y values here are all negative, and they're increasingly negative until we get to -1. And then as we go to the right here, they're still negative, but they become less and less negative until finally we reach 0 again, when we get to 2 pi, one full rotation. So what our graph looks like as we go to the right is we're going to have negative outputs, and they're going to follow the same pattern that we saw at the beginning, except they're going to be negative, they're going to decrease, and then slowly increase. Oops. So kind of like that. So I'm not going to plot every single point, but the minimum value is -1. And here we have our graph of y equals sine of theta. And as you can see, we end up kind of like with this wave graph, or this wave function. So here we can see kind of like the periodic nature where it repeats. If we were to continue this graph, it would continue with this wave pattern. So it repeats and repeats and repeats. And that's because as we increase theta, we end up going around the circle again and again and again. So we're going to see the same outputs, or the same sine values repeat. Cosine of theta is really similar, except for cosine of theta, what we're looking at is the x values. We start at 1, and then we slowly decrease until we get to 0. Then right away we start going to negative values until we get to -1. So our graph down here if this is theta, and then our output is cosine of theta, we start at 1, our maximum value, and then we actually start decreasing right away until we get to, at pi over 2, we get to 0. And then we decrease and become more and more negative until we get to -1 once we reach pi. So pi. And then we start to, that's our minimum, so we start to increase again. And then we'll reach 0 again at 3 pi over 2. So 3 pi over 2, and I'm just trying to match these up with what we have above. Here's pi, here is 3 pi over 2. And then finally we'll increase until once we have done one full rotation. In other words, once we reach 2 pi, we'll be back at our maximum, which is 1. And then our pattern repeats. So again, we'll be going down, reach our minimum, and then back up, and so on. And it also keeps going in this direction too. So we get the exact same shape that we see in sine. And sorry, I'm blocking a little bit of that last part. We get the exact same shape that we see in sine, except one way to think about it is we just have our sine graph, but it's moved over by pi over 2. It's shifted over by pi over 2. So instead of starting at 0, we're actually starting here. And then as you can see, as we go to the right, our graph matches exactly what the sine graph does. It starts at our maximum, and then it goes down and repeats. Okay, so this repeating wave that we see matches the periodic nature, where every time we add 2 pi, we end up with the same exact output. And so we see repeating. And then we also see a pattern between sine and cosine. They actually have the exact same shape. It's just one of them is moved over a little bit. Cosine, you can think of as sine just moved to the left by pi over 2. So these are the graphs of sine and cosine that we see when we consider our input as theta, an angle around the circle, and our output as sine of theta or cosine of theta. All right, so up here I pulled up a visualization of the sine and cosine, and also tangent, which we'll talk about later. Graphs of sine and cosine and tangent, and how they relate to the unit circle. This is just the Math is Fun website. I just Googled it really quickly. So here, as you can see, we start at theta equals 0, so our angle is 0. And our y value is this number here. So we're looking at the graph corresponding to this color. This color is, I think, yellow or green. I'm partly colorblind, so either yellow or green. I'm just going to say green. So we're looking at the green graph here, and we're starting at 0. And then as we increase our angle, we increase from 0 until finally we reach, at pi over 2, we reach 1. So we reach our maximum point on our circle over here, 1. And then we start to decrease until at pi we get to 0. And then we repeat the same pattern but in the negatives until all the way when we reach 2 pi, at which point we'll repeat that same exact wave. Cosine is the same. We're looking at the x values. So starting at 0, we start at 1, and then we start to decrease right away until finally at pi over 2 we get to 0. And then we decrease even more, looking at the negative x values until we reach our minimum of -1 at pi. And then we start to increase. So we go back to 0 at 3 pi over 2. And then finally, after one full revolution, we end up right where we started at 1. So that's this other graph right here, cosine. And the first one we looked at was sine. And as you can see, they're the exact same shape, except you can think of it as the sine graph just pushed over by pi over 2 to the left. All right, so lastly, I want to talk about the very end of 6.4. So this is section 4 of chapter 6, which is looking at transformations of these graphs. So we looked at graphs of sine and cosine. Finally, thinking back to earlier in the semester, we spent quite a while looking at transformations. And what we're going to be doing in the future is connecting these transformations with these graphs. So for example, here, our book gives us 2 different equations. We have y equals cosine of x, which is graphed to the left here. And then we have y equals cosine of 3x, which is graphed to the right. So what's happening here is we're multiplying the input by 3, which means we have a horizontal compression by 3. In other words, we're multiplying all of our inputs by 1/3. We're squishing it by 1/3. So the example here is, as you can see, at pi over 2, cosine is 0. So we take pi over 2, divide it by 3, and we get pi over 6. So now cosine of 0 at pi over 6. Same thing here. At pi, usually we're at -1. To the right here, we have pi over 3. So divided by 3, we reach -1. So taking our cosine graph and then just squishing it. So it's that same wave, but it's kind of like pushed together. So it looks like it's more wavy. It's just repeating more often or more quickly as we go to the right on the graph. So you might be given examples where cosine or sine has been changed or transformed in some way. We just need to use our previous knowledge of transformations to help us think about what these graphs will look like and how it changes those the waves that we see for sine and cosine graphs.